I'm Andy Kim, your instructor for the Data Science in Finance part for current topics in finance. Last week, we had a class introduction, and then for my part, I told you about the current, how do you say, the hierarchical structure of economic studies, right? Those theorists. Um, Even though you may believe that the theory is like there's no distinction between the econometrics versus mathematics from your perspective or MBA's perspective, but there is a significant distinction between even among economists, even among those scholars, right? Those are doing with pure mathematics, called economists in Chicago, Minnesota, Carnegie Mellon, versus those econometricians who is working with the data. Okay, so that part was more about you economists, please come down to down to earth and then deal with this data. What's going on over here? Okay, for MBA guys or students' perspective, management perspective, student perspective, you guys have been working with the case studies so much, but we have to bring you up. Okay, so much so that you will be more comfortable dealing with many cases in called a sample. Okay, and then working with a big data even more, right? Not just a sample of 30 or 100, but millions of observations like that. So we have to familiarize in that sense. So for my part of the job is to bring both economists and this the students to middle ground. Okay, somehow. Okay, this is the attempt like that. So when it comes to big data, okay, what does it mean to be big, right? We're going to talk about that today, and then we're going to go through some basics of R coding using some of the textbook example, and then can we replicate, right? What's the code over there to run some kind of regressions, right? We're going to go through some basics of it, and then we're going to talk about something called Benjamini Hochberg algorithm, or those kind of things to basic criteria, okay, about this process, okay, which is talked in chapter 1 and 2, or 1 and then the chapter before, right, in the textbook, uncertainty part, okay. So what does it mean to be big in big data? Big in both the number of observations, the size, and the population. Almost it's going to be like a population study instead of sample study. Even if it is a sample, it's going to be huge. And then in stock market event study or stock market studies in finance, we say universe, crisp CompuStat universe. By the way, I'm going to upload those crisp CRSP data set and the CompuStat data on Google Drive so that you will be able to download and play with this in the future. Okay? Because those crisp and CompuStat is is not just a random sample, but it is a universe. All the stocks listed in the market, those data is tracked and then it is downloadable. So we call it the universe over there, crisp universe, CompuStat universe study. Okay, the number of variables in the dimensions p is huge. The number of variables, by the way, when it comes to CompuStat, which is the accounting data of the United States, you're going to see each line item of your financial statements. For example, cash and cash equivalent, and then accounts receivable, and then notes payable, or even in accounts payable, some of the items that you reserve, right, for loss, right, loss reserves for accounts receivable. All those line items should be single variable. Think of it as a column, okay? Your sales, total assets, or net income, all those things will be simply one column. And then your row, okay, number of observations, will be one company's one time point value. Okay, those will be one observations. So think about Samsung Electronics, right? One company, many fiscal years. The N will be big. And then for Samsung Electronics, you're going to have sales, net income, operating income, assets, and blah, 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 all the way down. How many columns would you have? Hundreds and hundreds of columns. Okay? Of course, how many observations? Many years, many quarters. Plus, in Korea, you have 2,000 companies listed in the stock market. In the US, you have like 5,000 to 6,000 stocks listed in the stock market. And imagine the whole world, okay, the capital market, how many stocks would you have? Yeah, that's what we mean, okay? So that's not even big yet, because when you go to tick data kind of things, tick by tick by tick by tick, what do you mean? Microstructure trading data for each stock, okay? Samsung Electronics, there is a tick data that tracks the transaction of buying and selling of the stock every millisecond. Not just a second. I said millisecond. 1000분의 1초, right? And who bought that and then who called that for bid and ask, and then at what price did they quote, and then at what price was it transacted, and then who did it, right? Like if it is foreigners, what's the nationality, right? A huge data is there for you. Size N is huge. In these settings, you can look at each individual variable and make a decision where the t-test will be important, or choose among a small set of candidate models where f-test would be important. F-test would be, involving multiple variables, which, choose among a small set of candidate models. So each regression model, you will have some explanatory variables on the right-hand side. Which set of variables suits best to explain the dependent variable? And plot every variable to look for interactions and transformations. Interactions, well, two variables, multiplication of these two variables. What's the interaction effect, or 교호작용 in Korean terminology? And transformations, well, sometimes you have to do log transformation, box-cox transformation, all these kind of things, right? Some big data tools are straight out of previous statistics class, like linear regression, and some are totally new. Yeah, PCI, I told you about this. Random trees all require different approach when N and big gets really big. And then all of our analysis will be conducted in R. This is the real deal. This is industrial strength software for data analysis. It's free, yeah. And then cross-platform and hugely capable. And then during my PhD studies, our school supported SAS, and then I thought, SAS is, something expensive software, so that the schools pay for me. So I like that. So that's why partially, I just stuck to SAS. But my friends in engineering, they resorted to R, and then, why don't you do it for free, So that was, the deal over there. And then together with Python, R became like really one of the two dominant software that you have to be able to use. Companies, they can save cost, right? They don't need to spend money to do this big data analysis. Whereas if they resort to SAS, they will be like, spending a lot of money. Okay. For me, no, wait a minute. All right. So, so R for free. Yeah, why not? Right? Just do it. Yeah. And then for me, like I used to teach it in different language like SAS before, and then the students were complaining, right? In the end, I have to translate it back to R or Python. Why did you teach it in SAS? So I switched it. Anyway, so you will benefit it, hopefully. And then also I will also switch into R guy over here. So huge strength of R is that it is open source. It is also why it is sometimes a bit unpolished. So you will see a lot of sloppy, a little bit of codings in here and there. But what is that? The population in the globe, right? The more number of people are doing it, the better code will survive, and then you are more likely to end up with a better code by Google searching. R has a core to which you can add contributed packages. These add-ons are as varied as the people who write them. Some are specific, others general. Some are great, some suck. Yeah. R is not without flaws, but neither are the other options. Now, every now and then, you will have to install packages from the internet. Some packages will be correctly installed in your computer. Some packages may not be installed properly in your computers, right? For example, one of the packages that I tried to install did not work, did not get installed in my desktop computer over there, right over here. This is Alienware, which is supposed to be state-of-the-art gaming computer, right? In the whole world, hopefully. Yeah, do I play game with this? No. But I have, unconventional data that I have to work with, so I like it. RAM is huge, that's why, 64 gigabytes. So that I purchased it. But unfortunately, some packages did not work. So I turned to my laptop over here, which you see over here. Lenovo gaming computer, again, right? Why? Because of the high RAM, 32 gigabytes. And then some R package worked over here, whereas did not work over there. So that may be to switch into Lenovo, right? For instruction purpose, right? Likewise, you may find difficulties, right, in installing certain packages to your computer, but you need some help, I guess. You need to Google search it. Why doesn't it get installed in my goddamn computer? And then you will have to open up that question. Perhaps you could ask it in the our iCampus question and answer board, Q&A board. I may not be able to answer your question directly because I'm also, first time doing it, but that opens up a chance for the rest of the group, right? Anybody contributes and help out the other guys installing or coding through this iCampus stuff, right? I will give you participation grade up, okay? And then the more and more you add and contribute, the better you are. So throw out some questions and give other students a chance to, contribute. That's great. You yourself, by asking those questions on that bulletin board or Q&A board, you also add value. So I'm going to add some points to you, okay? But don't try to flood it too much, but let's do it. Let's be productive for each other. That's our spirit. So that's that. R is not without flaws. Yeah. Some students prefer to wrap R in IDE, Integrated Development Environment. For example, R Studio, and that's where I'm working at, right? R Studio. Install those things, please. The barrier of entry for R is its command line interfaces. You type commands to get what you want, so the learning curve can be steep, but it is very worthwhile. You have code of saved commands, so you know what you've done, similar operations. Interacting with computers in this way is a big data skill. Okay, and then you will realize, right, a lot of engineering guys in computer science, right, all those guys, you realize they have been doing the same thing, right? All those questions they were asking in the Google and GitHub, and then they were, adapting to this environment, and then you have to be one of them, okay? And another thing for plus, a big plus for global business administration guys, as opposed to, or global economics guys, right? As opposed to Korean engineering guys, is that you guys are good at English, so you are not afraid, okay, not as much afraid as those engineering guys in reading and writing in Google, and then throwing questions on Google in English, and then think about how many people are there in our using people, right? Absolute majority of them are English speaking. All those the good sources are written in English. Koreans, you have great Korean engineers and programmers, but vastly outnumbered by English speaking engineers, right? So, in that sense, GBA and then global economics guys, you are, in advantages, right? Compared to regular engineering guys. This is one of the things that GBA graduates working in Naver and Kakao as programmers told me, okay, told everybody else, that they're good at reading and writing, okay? They're not afraid to dive into this programming environment in Google. So go ahead and conquer it, okay? At your age, come on. Even my age of almost 50, I'm delving into new area. And then it's like a sink or swim kind of, struggling that I'm trying to do from now, okay? Why not you do it too, right? Let's do it, okay? Yeah, you may say 치매 예방 to me, but yeah, it doesn't matter. I just like to explore. 산이 있으니 간다, right? Why do you climb up the mountain? Because there's a mountain. Because there's new language, I'm just going to conquer it. Let's do it! Yeah, right. So, interacting with computers in this way is a big data skill. Yeah, let's do it. All code for lectures and homework will be available online. The best way to learn software is through imitation. Monkey sees and monkey does. Monkey sees and monkey does. We're going to do that, okay? There are tons of resources. See the website and the syllabus. And computing R. To start, click R or R. Just type R in terminal as it is on a basic on assigning names, right? So from this part, let me start with my R Studio. Okay, R Studio. Here I have to be careful about this microphone volume because I'll be a little bit away from it. But let's do it. So R. First of all, make sure you install R, okay, in Google. Once you install it, you will be able to find in your start button, you can see R Studio, okay? Click it and open it, and then you will be able to launch R, okay? R over here. So if you start it, you're gonna have of course, once you install R Studio and then double click it and start it, then the R Studio software will ask you, you don't have that R source code this kind of thing. Did you see? Do you see this thing on the center, at the center? R, right? This is the very core R that you need to have to be able to run the whole thing, R Studio. So R Studio is a kind of an interface. The way I understand it is an interface that makes it more user-friendly for you. Okay, user-friendly for you. So that here, so that the R Studio will ask you to install that core R. And then once you install that core R, then R Studio will function. normally, okay, like this. The moment you open up, this R Studio, okay, it would pop up like this, and then you will have four windows like this, okay, four windows. One is, I guess some of you are, I mean, most of you are familiar with this basic setting, so that I should not spend much time on this one. But here on the left hand side, upper left hand side, this is the window that you make and then write up your code and then save it as a code. Like for in my case, I save it, okay, as lecture 2 demonstration.r, as you see over here. So let me for example, I could save this guy as some R code. Where shall I save it? Well, I will save it at yeah, in my teaching C, in my teaching 2020, yeah, come on, and then current topics in finance, and then R. Okay, so I'm going to save it over here under the name lecture 2 demonstration.r. Okay, so here, that's how I would do it. Okay, so you can record or save your codings each time in a different names or same names like this. The thing is, as always, once you type something and then make a modification, you will see a small star showing up at the file name over there. Star means that, oh, you should save this code. Before you turn off your computer, make sure you save it. Control S, otherwise you will be screwed because you will lose all your additional codes that you wrote during their computer was on. Okay, so each time make sure you Control S. Okay, make it your habit. Every 5 minutes, just Control S, Control S, Control S, and Control S, and Control S. That's something you have to do. Okay, now, so that's your window for typing in your codings, and then each time you write a code, like what? For example, over here, let's create a variable. Yeah, let me rm. Let me clean up all the existing data that I have in my computer. So are you sure you want to remove all the objects on the environment? Here on the right hand side, you can see a data set that you created. So previously I created a lot of data set and then variables, so that's why I have a lot of messy things over there. But I'm going to clean up over here, okay? So nothing shows up over here. When I turn on the computer, it will look like this, and then it will look like this as well. Clear everything, and then over here. So the clearing sign here, you see the brushing, okay? Brushing and cleaning. So I started over here, then what? So let's create a variable called big A. Each time you run it, Control Enter. Okay, push Control and Enter. You will see a variable created over here in the right hand side. Okay, and then that's a scalar or skala in Korean terminology. Scalar, right? And then scale. Yes, that's a scale. Scalar. Why is it called a scalar? You will see it now. B, let's create a vector. Okay, it has 3 elements, 1 to 3. So here we are. Okay, C, and then you see either arrow like this, yeah, arrow like this, or equal sign should be the same, okay? But it's just habit, right? They use it arrow like this to impose a certain values or vectors to a variable, okay? A, B created, A scalar, B vector. Now let's do a scalar multiplication of B by A. So 1, 2, 3 vector will be multiplied by 2, which will be upscaling, okay, to like this. Then it's gonna be like 2, 4, 6, right? Scale up, scale down. That's why we call it scalar, right? It scales up a vector in a certain magnitude, okay? All those mathematics jargon in English makes sense. There's a reason why they call it that way. Anyway, so and then we create another scalar based on A and then a vector element of B, third vector element, which is 3. So 3 plus 3 plus 2 should be what? 5. Is that right? So C is created, and then you see on the right hand side the value of C, the scalar, is nothing but 5, right? You see that? And then we want to double check it by Control Enter. On the left hand side below, you see in the console panel, you see all those results coming up. Good. And then the length function asks the computer, well, how many elements do we have in that vector? Okay, how many elements? If it is a matrix, how many column vectors do we have, right? So length over here, over B, we have 3 elements, so length is 3. Okay. ls parentheses list up the variables or data sets that I have created so far. So by this command, you will see 3, okay, because we have ABC elements over there. Okay, list up. Oh yeah, not 3, but it lists up the variable names, ABC. Okay, ABC variable is shown. Now, okay, fine, good job, computer. I don't need ABC. I want to clean up, right? Well, I could push this wiper, what's that, the brush icon, or here I could command rm, remove, okay, like this. R can read almost any data format, set the working directory to where you store data. Working directory, what the heck do you mean? Well, each time you work with data, you need to have some file path. Okay, you need to have some working directory. I mean, the directory that you store your data that you're gonna work in this R coding. Okay, so what is your work directory? Okay, you have to specify it. Before that, let's check our current working directory if it is not properly set up. Okay, by default, it will be like something in your My Document kind of places. But in my case, right, I set up already. Okay, you see over here, get WD, get working directory parentheses. Okay, ask the computer, get me the work directory, currently set up work directory for me. Okay, it will give you an idea about the file path of your working directory. Where is it set up right now? Okay, once you run it, and then you will see, oh, that is the file path that the computer recognizes. But the thing is, the existing file, the work directory file path will be very long, which will be screwy as you go down the road, okay, in this class. So my habit, or let's make it a habit, to place and then set up a work directory in a very, very simple place. And then you just place all those data in that work directory, so much so that when it will be easier for you to import those data. whenever you install whenever you download any data. Okay, so beware of so here you have to set up your file path using slashes, either forward slash or backward slash. In the console you see forward slash c dot dot forward slash data forward slash r. Okay, fine. How about this? I want to set my work directory as a C data R. Here I have to take you to this C the Windows Explorer. Okay, open up your Windows Explorer and then let's go to C drive over here. C drive. Create a data folder. Okay, because I'm a data guy, I have always tried to have data folder in my C directory, C drive. Why not in my document drive? Okay, fine. Whether you use my document folder or whatever, I don't care too much. But that work direct but I believe my document folder path will be very long compared to this method. Here you just need c dot dot data dot c dot dot slash data slash r. Okay, under data folder, create an r folder, and let's use this as our default work folder. I want you to follow this so that you will be in the same page as me, each class, all right? C data R folder, okay? And there I got all those data related to this class, okay? Got it from Matt Taddy's web page, right? So that's gonna be it, plus other data, okay, crisp, compustat, all these kind of things, and Korean stock market data. I'm going to use this folder as well. Anyway, so set work directory like this. How about this? Okay, run it, and it says what? Error. No, it says no. Why? First of all, it's backslash, right? Forward slash, just once it is okay, but backward slash you have to slash slash 2 times, slash, right? So you need to backslash in place of 2 backslashes in place of one slash, right? Good. Over here we want to import. Let's play with pickup truck data. Okay, pickup truck, 용달차, right, in Korean terminology. Good. So first, make sure you place the pickup truck file, pickup CSV, in the right directory, which means your working directory, i.e. C data R. So let's check it over here in R folder. Once you click this over here, you will see file path C data R. You see it, okay? So in this folder, let's make sure that pickup data is here. Pickup data, pickup.csv. Why is it called CSV? You must know this. Comma, separated value. That's why it is CSV. All those data, okay, storage format is like comma separating. Okay. Once you open it, the file size is only 1 kilobyte, right? Very small data. Come on, why is it not showing? Excel usually shows it very well. Perhaps it is slower because I'm using this video recording software. Forget it. Okay, so what do I do? I'm going to import this and then name this file as trucks, right? Trucks. Notice here the maker of this file is American guy. That's why it has S over there. If it were Korean guys or Chinese guys or Japanese guys, we would be like truck. Okay. Now, um, no need to run, and trucks over here, right? And then the data are then in the working directory over here, RAM. Once you click this name of this data frame, we call it data frame. I just call it data frame or data set or matrix, same thing. Okay. Click once, it's gonna pop up over here on the left hand side, as you see, trucks tab, and then it shows there are 1, 2, 3, 4 columns, and then many rows. If you scroll down, 46 rows. Okay. You can sort it by each variable like this, right? By clicking it. Okay, A, B, C, D, or years or whatever. So you have years it was produced. Okay, 몇 년씩, right? What year's model is it? And then mileage, how many miles it ran, and then the price of it. Okay, and then make, which is like the maker name, the brand name. Okay, Dodge, Ford, GMC, what is that? General Motor Corporation. Okay, fine. Now close it. Yeah, make it your habit to close it. Okay, otherwise I don't know if it's going to be working if you manage your data and then increase or change the data into something else if it is open like that. Usually SAS does not work if you open up a data and then try to change it into something like, right? So make it your habit to close it. Anyway, once it is over here, it is on your RAM, random access memory of your computer, instead of in the C drive or whatever. Okay, now it is flexibly moving using your RAM. And having a high or big RAM capacity in your computer is necessary. Okay, like what you see over here, gaming computer. Okay, great, because it has huge RAM capacity. I told you the package installing did not work for this one, sucks. But the laptop over here that I have with you, right? It matters in big data management. Buy a better one with high RAM, okay? It matters. Don't say, oh, I'm a 문송의 문과생, right? You never know, okay? And then you are finance guy. You have to be directly competing with computer science guy, and you have to be better than them. And then this computer capacity matters over there, right? So don't say I'm gonna work with the minimal, capacity computer. RAM has to be big for your computer, okay? Try to find a way to work with that. Your budget may matter over there, but for that case, you may explore into Amazon Web Service, AWS. There you subscribe, monthly fees, right? Cheaper alternative, right? Monthly subscription fees, and then you can use higher RAM computers, right? Servers, you can access them. Okay, some of my RAs are doing that, so notice that. I'm not engineering professor, but my RAs are doing that. Anyway, trucks is a data frame, and then you can use index names and numbers to access the data. And trucks over here, okay, what the heck is that? That is trucks squared bracket, row column, row comma column. So first row, comma, empty means every column. So tell me the first row observation, please. First row observation. Okay, 행, 열, 행, 열. Wait, I just ran too much. Okay, the first row. Okay, the first row, year, miles, price, make of the first observation, 2008 is shown like this. Okay, that's fun. How about 10 rows? First 10 rows. You can specify it like this. Okay, good. How about the first column? Well, first variable. You see the year will show up. But notice that we have about 46 observations, so that we're going to have the 46 observations of the year column will show up like that. And then the trucks of year variable, which is the same as before. And then trucks and year in this format, you can tell the computer the same thing, right? To do the same thing again and again. Whether you use double quotation or single quotation, it works the same way. And then trucks here, give me the truck mileages, right? If the mileage is, what is that? More than 200,000 miles, like old clunkers, right? Over here. Mileage 207 plus mileages, and then 215 mileages, right? Those observations, 2 are shown, okay? Only 2 of them. Now, and call R's function on the data, okay? So, number of rows in this data set, I wonder how many? 46. And col means what? Number of columns, right? And then and length is the same, number of columns. So length in case of matrix, it's about the number of column vectors inside. Okay, good. Summary is like, well, give me the summary of all these variables: year, miles, and price, and make. Okay, fine. So minimum, maximum, median, first quartile, third quartile are shown, right? Minimum, median, and mean, right? Good. Year, miles, and price, those are numerical variables. So rather we are happy, but makers, these are character variables. You can see that in the class information over here. Class, character, okay? Now, that's summary function. And then back to PowerPoint slide lecture note 59. I'm going to come back soon. So, slide 59. Yeah. Okay. And then slideshow. Yes. I want to switch it. Yes. Much of the world revolves around flat files, txt, csv, whatever. Okay, xlx, flat file. What do you mean? 2-dimension, rows and columns, right? Rows and columns. But how about 3-dimensional, right? There could be a lot of tabs in it, right? There are 2 other dominant broad storage analysis model. For this one, there are 2 other dominant broad storage modes or analysis modes. Number 1 is SQL, structured query language. Number 2 is distributed file systems, right? SQL databases, well, it's a model of fast rational queries of structured data. Select Apple ID, Apple price from grocery list, where Apple the column is green, color is green. Examples are MySQL and Oracle SQLite, and then Teradata kind of things, right? What do you mean? Select Apple ID kind of things. Well, SQL language, once you learn it, right? How much SQL are we going to cover? I don't know in this class, but maybe some part of it. Okay, it's like we have multiple matrices, right? One matrix and the other matrix, and then out of matrix A you select variable Apple ID, and then select grocery list in your matrix B, and then pull it out and then merge and then create a new data set or new matrix. Okay, and this kind of things will make your life easier. Okay, and then manage your database in a more efficient manner, right? So examples are MySQL, Oracle SQLite, and Teradata. The analysis analyst typically pulls data from the database with a SQL query, writes this to a flat file, then reads the flat file into R. The packages like RSQLite can also read directly from SQL databases. After extraction, you analyze the data in the memory. Now, number two is like distributed file systems like Spark and Hadoop. Holy cow. Honestly, I am not experienced with this Spark or Hadoop at all. Okay, so don't worry about this. I'm not going to screw you with this one. When the data is unstructured, like log files and raw text documents, like media coverage data, kind of things, right? Or your accounting quarterly earnings announcement, right? Your management interviews or transcripts, all those things. Or pictures, right? The CEO's face picture, or his interview voice files that I use, right? May be usable over here, right? Or too big to fit in or fit on a single server, we turn to DFS models, right? So far, my data, I can store it over here, or my external hard drive, no problem. But if it gets bigger, much bigger, right? External hard drive, not just external hard drive, the server level. Holy cow. Then you'll have to use Hadoop or Amazon S3. The data is scattered across many machines with a key that tells you where all the pieces live. Okay. Analysis uses a high algorithm framework like MapReduce, partition data into small chunks, analyze each independently. Like parallel computing happens like this. Don't get freaked out. We'll not use it. Don't worry. Okay. Maybe in a couple of years later, I would be using that. Hopefully. Let's see. This is big data. Each chunk analysis uses the sort of tools we will cover in the class. We will talk more about distributed algorithm later, perhaps not. And throughout class, we always focus on scalable techniques, right? Regressions and PCA, all these kind of things. Basic elements in R, numeric factor logical character variables, right? So the values in our data frames all have classes. Numeric values are just numbers, and factor variables are categories with levels, like categories level. Low-fat milk, regular milk, all these kind of things, right? And then maybe if it is ramen, then what? Extra hot or reasonably hot or mild, and then things like that. Logical values are either true or false. In other setting, they call it Boolean kind of things, Boolean. In Python, they use it. They use this terminology, Boolean, true, false, right? And then character strings are just words or messages like "Hi, mom." All right. We have plenty of tools to investigate and manipulate these as numeric or factor or class or levels of these variables, right? R has functions that look like f parentheses, argument, argument, argument. Yeah. It creates, you can create new variables like, for example, L price, which is log of price. There, let me go back to the R codings over here. Okay. Back to RStudio. Yes, RStudio. L price over here. Okay. Log of trucks, right? There you see on the right hand side, after I punch in enter, you see L price created. Okay. Data over there, trucks. If I clicked it, then the matrix popped up on the left hand side. How about L price? It doesn't show up. It doesn't pop up on the left hand side. Now we only have the information about this variable L price over here. It's a numerical variable and it has 46 observations, and then the first observation should be 9.62, and then things like that. What is that? Well, this was taking a natural log of price variable in trucks data set. Okay, so trucks and then dollar sign and price. It works more like a Korean style of naming. Okay, your family name and then dollar sign and then the variable name. Okay, first name and dollar sign and no, last name. Okay, family name, dollar sign, your first name. Okay, kind of things go on. Interesting structure. Now L price was created, log of price, and then log base what? Log base E, the natural log E. Don't think about base 10. That's high school in 문과 or only, right? Non-engineering guys. But we are going into engineering, so we have to be like natural log E. 이과 versus 문과, the difference is E, natural log E. Okay, so that's it. Now you are 이과 from now on, or engineering guys. Okay, good. And then here you created a variable, but if you at this moment, okay, until this moment, right? If you click trucks, nothing happened because we did not touch on this one. Okay, we just extracted one variable and then played with it and then created one variable. Now the next line, we want to create L price variable and then stick it into our trucks data. So do it. And then if you click it again, trucks shows up like this. Voila! There's one more variable coming in, L price over here, which is natural log of this guy. Over here. Okay. So that is a creation of one column in our matrix. And add them to your data. Yes, I did it to find out how a function works. Type question mark and then the function f, or whatever f the function may be. For example, for this part, go down over here and then I type question mark and then log. Okay, log, and then on the right hand side it shows logarithms and exponentials, and then it says that log of parentheses something is natural log of that variable. Okay, log base 10, it has to be log 10 parentheses x, right? Well, this kind of log being natural log is quite prevalent almost anywhere, SAS or other functions, right, in other software. Anyway, so that's that. Once you created it, you want to plot and then draw some pictures out of it. Okay, fine. Plotting is super intuitive. Plot, parentheses, truck, and it says truck price from 7,000 to 10,000 or something, like that. Oh, no, sorry. This is about log of price, 7 to 10, log of price, and then index is the number of observations, index for the number of observations. First observation, all the way down to 46 observations that you see. And then, how about price itself instead of log of price? Right, it looks like this, 5,000 down to 200,000 or something. Is that right? What is it? Yeah, it should be 5,000 to 20,000. I'm sorry. Yeah, 5,000 to 20,000 going up. Okay. Plot price, but this does not work. Okay. Plot price error. It does not work because inside the parentheses you have to specify the first name and last name of this variable, the matrix name, dollar sign, and the variable name. If you don't specify the matrix name and dollar sign, it will try to look, the computer will try to find the price from this values list. Okay, values list. There you don't see any price values over here. So it says error. Fine. The next is histogram. Okay, histogram. Yeah, statistics is all about, thinking about the histogram and then strategize based on it. Yeah, this is the year histogram. You see more extreme observations on the left hand side. extreme old cars are there. And then over here, price, it is skewed to the positive, which means there are some trucks which is extremely expensive, $25,000 worth. But absolute majority of them belong to this low price ones, $5,000 worth, right? And then for this part, right, as long as price is skewed, right, to the positive, you will have a lot of troubles in running regressions. So why? Because the distribution has to be normally distributed rather than positively skewed distributions. So we make it a habit to take a natural log of it. And then once you take the natural log of price, what's the distribution that you see? Well, the histogram is like more like a symmetric. Of course, here's a blip over there, but use much better in shape than the previous distribution of raw price. Now I want to go back to the previous picture of histogram of price. How do we go back? Well, here is the arrow in the picture panel. Okay, picture panel, you can back and forth like this. Okay, and then I want to draw a histogram of mileages. All right, again, this is positively skewed because some trucks are exhaustively used to the extreme degree. The rest of them are reasonably exhausted over here. Now, one graph, one screen, okay, that you see over here. Let me go up, hello, and then over here, pull it up. One graph, one screen. How can we place multiple graphs in one screen? One screen over here, one window. Well, there's something you could try is set up. You can give a direction to the computer. I'm going to make multiple graph in one shot. It's like a picture matrix that I want to create. One row, 3 columns. We're going to create it. Okay, give a command like this, par, and then mf rows. Okay. So there I give 3 commands about histogram. Right. Then we see histograms of year, miles, and price like this. Okay, fine. How can we copy and paste the graphs on Word, graphs from here and paste it on the Word program or PowerPoint? Well, you may think about right-clicking and then copy images, but that does not work. So what do? Well, here, if you look at the icons, right, there are some people who wondered and then had the same question like you before. So that's why if you click, there will be some answers. So copy to the clipboard, okay, and then it shows up like this, but it's not the end, okay. You click copy or button down there, and then open up your shall I open up a Word file? Yes. And Control V, paste it, and voila, it shows up in Word document like this. One by one you can paste it. Easy, right? Good. You can also save it as image file or PDF file if you explore something of it. Okay, but I haven't done that. Well, the next one is about box plot. Okay, box plot. A lot of you are experienced with this box plot. I seldom used it, but let's try it. Control Enter box plot. Okay. What does it show? Well, box plot shows median and interquartile range, which is your first quartile, 25th percentile, and 75th percentile. It just wants to show you some distribution idea about the data. And those are boxes over here. Okay, boxes over here. and then you see some whiskers like a cat whisker, 수염, right? On the extreme up or extreme down. Okay. Um, well, how does it show? Well, this is about 1.5 times the interquartile range, they say. 1.5 times up and 1.5 times down. Okay, the interquartile ranges. Um, Remember, this is not necessarily the minimum or maximum. Okay, interquartile range 1.5 times. So let's do it like this. For different variables like year, miles, and prices like that. But sometimes you want to check out the extreme values like the minimum and maximum, and you want these whiskers to show that minimum and maximum instead of 1.5 times of the interquartile ranges. So if I do that, it shows like this. You see that difference, okay? Some variables over here, okay, previously showed like extreme values are over here and shown in maximum, right? But it's not covered by this whisker, okay? But afterwards, right, those maximum is covered by this whisker, okay? So that's it. Scatter plots are the ones you want to study as well. It is very informative, right? Scatter plot.